Okay, I'd like to introduce our next speaker. JBO is from DC 9723 in Tel Aviv, Israel. Uh, Jonathan Bar Or, JBO, is presenting the Sandcastle, the state of the macOS sandbox through the lens of Office macros. Now, for those who don't know, JBO is a regular speaker here, and his presentations are usually very, very good. So I'd like to welcome you here, JBO. The macOS sandbox is a powerful tool for application security and hardens Mac OS Office to a point where they're not wildly used as an entry vector. Or are they? In this talk, we will dive into sandbox escape mechanisms on Mac OS, as well as present a few techniques for potential generic sandbox escapes. Now, John Barr, or JBO, is a principal security researcher at Microsoft, working as the Microsoft Defender research architect for cross-platform. Jonathan has rich experience in vulnerability research, exploitation, cryptanalysis, and offensive security in general. So we welcome you, JBO, and take it away.
Thank you, and thank you for having me. It's a real pleasure. I couldn't make it to DEF CON physically this year, so I'm grateful for the opportunity. With that, let's get started, I guess. I got the introduction already, so not a lot of other stuff. I would say that I work at Microsoft. I think it was mentioned. I'm a security research architect at Microsoft. I focus on Linux, macOS, iOS, Android, routers, cameras, Chrome OS. So interestingly, things that normally do not run Windows. One other thing that I can say is that I'm in charge of internal offensive security for Defender, and that includes simulating attacks, tampering attempts, and continuous red teaming. And you can feel free to follow me on Twitter or X or however it's called. I post once in a while. So a bit of motivation about Office macros. In Windows, Office macros are basically a very common method of gaining initial entry vector. On Windows, you have something called Defender Application Guard, or UpGuard for short, and it's actually getting deprecated. But the idea, which was a very good idea, is to use basically spin up another virtual machine right next to your host that would present the document there. So any attacks that happen on that virtual machine, but that's no longer relevant because A, it's getting deprecated, and B, it's only in Windows. In Mac OS, however, I mean, you don't have that kind of technology. And what happens really is that apps generally, and Office in particular, is heavily sandboxed by something called the Mac OS sandbox. And there is this question on how much are Office macros used as an entry vector these days, right? So that's the question that we'd like to answer today. A bit about the macOS sandbox, if you guys are not familiar, it's a set of customizable rules that are enforced on macOS apps. Basically, things like, oh, can my app access the network? Or what kind of files does an app have access to? Or can an app print the document? And so on and so forth. And it's well documented by Apple. And interestingly, to publish in the App Store, in the Apple App Store, your app must have sandboxing rules. So that's something that is very Apple-esque thing to do, to force developers into security. And obviously, if you have a process that runs inside an app, the child processes of that process are also sandboxed, because otherwise, what's the point, right? To create the child process, and if it's not sandboxed, then game over. And you can view the macOS sandbox with the CodeSign utility. I hope that you guys are able to see the screen well. The idea is that you don't have to remember anything here, but this is basically the Microsoft Word app. And in the Word app, you can start seeing all the entitlements that the app has. And some of them are basically the sandbox profiles that the app has. And this is where our journey began. We'll start with some historical data, and then I'll show my original research. So the Office sandbox rules in the past basically have this kind of sandbox rule. And you can see you don't have to like understand the syntax or the dialect here, but it basically says you can allow all file reads and all file writes on everything that is a regular file that starts with that adheres to this regular expression, which is basically starts with a tilde and then a dollar sign, right? That's basically what it says. And if you remember from Windows, whenever you double click the document, it would show you some sort of like a weird tilde dollar whatever dot docx, for instance. And apparently, Microsoft Office uses that to cache some data about the document. So basically, when Microsoft decided to start Office for Mac, they decided to move that functionality, but it basically means that you have to allow writing to those kind of files. So that's kind of in 2018. Basically, it was found by Adam Chester, I believe, from MDSec, that you can drop this poc.plist that starts with a tilde and then a dollar sign to a library, a launch agents. And this, if you're unfamiliar with Mac, this basically registers a launch agent, which is kind of like a service, but not really. And basically, the idea is that those launch agents are unsandboxed, right? So it's like writing to the registry, if you will, if you're coming from a Windows background. So that's like a very logical sandbox escape. It's the only sandbox escape that is very Office specific, and it's still worth mentioning. So basically, that was the idea. Launch agents, as I said, is a persistence mechanism on macOS as well, and it's launched by launchd, which is the number one process, literally PID equals 1, which is not sandboxed. And this is how the attack looks like. So you have word dumping, let's say with a word macro, tilde dollar poc.plist, and then launchd, which is the launch daemon kind of reads that plist from the launch agents directory and then launches it, right? And you can do whatever you want here. And the conclusion here, and that's the main takeaway, is that making unsandbox processes execute child processes is a good idea for attackers if you want to escape the sandbox. So that was the attack in 2018. The fix was a Microsoft fix. It's not an Apple fix because this was specifically in the sandboxing rules. It's basically very easy. It says something like you can read or write files that have this regex just as before, but you will deny all of the file reads and file writes in particular. Sorry. That either start in the home directory library launch agents, that's number one. And number two is library application scripts, which is another directory that could be abused. We will talk about that later, so keep that in mind. But basically, the library launch agents drop is now denied by the sandbox. So that's like a one-off kind of fix. It's not a deep fix. It basically says, oh, no more line changes for you. So the next couple of sandbox escapes that I will mention, again, our history shows us, are going to bypass with IPC, with inter-process communications. And in this case, we're going to use archives. The launchd process that I mentioned before, this guy, the one that runs the plist file, it controls launch agents and launch daemons, which is another type of kind of like a service in macOS. It basically controls many other things in macOS, and when I say many other things, I mean mostly everything. And one other thing that launchd controls is launching apps when you double click something, right? And this feature is known as launch services. And you can double click or just run the user bin open command, which will basically open the default thing. And it also opens, like, for instance, if you do open on an HTTP, it will open your default browser. Or if you open on a text file, it knows the association between text file and the default app, and it will show you it will open the right app for you. So that's kind of like the functionality of launch services. It's able to launch apps. And launchd will only launch apps that are already installed, obviously, right? You can't just say, hey, run this process. It has to be an app. And there is a difference between apps and processes in macOS. Basically, an app is a directory structure that will also have an executable in it, right? So it has to be a specific directory structure. And there is this question of what apps are already installed and can run code. And we have an app called Terminal. The Terminal app basically is the one that runs ZSH or Bash, if you will, but ZSH is the default one in macOS, and it will run a file called .zshenv. If you drop .zshenv to the home directory, it will just run whatever commands that are in there. The issue is that you can't write .zshenv file because you have file name restrictions. You have to start with a tilde and then a $sign. And then it was found by Madhavbat, and I'm sorry that I butcher his name, to use something called the archive utility. The archive utility is another app. And interestingly enough, it's the default app that opens archives. Interestingly, it automatically extracts files in the same directory as the archive, no questions asked, no user interaction by default, so that's awesome. And that's the exploit. You basically drop it $poc.zip in the user's home folder, and that contains the malicious .zshenv file. If you remember, we can drop any file that starts with a tilde and $sign. And then basically you trigger the open command to extract, to basically kind of simulate a double click on this zip file. Because of that, the archive utility, which is not sandboxed because it's run by launchd, will extract the zip file and create a .zshenv file. And then you can just trigger terminal to automatically run the commands from .zshenv. So this is how it looks like. You have Word. It will dump the zip file. You can do that because of the file name is okay. The file name itself, the file itself, the contents are attacker controlled completely. So the attacker can prepare a zip file with this name that contains a .zshenv file with malicious commands in them. Word will use the inter-process communication to launchd. I didn't mention that, but the open command that is used by the exploit here basically uses XPC, which is kind of like a weird IPC in macOS, to tell launchd, hey, please open this zip file. Launchd says, okay, zip files are associated with the archive utility. Archive utility is now unsandboxed and will extract the poc.zip file. It will extract the .zshenv file. Again, because it's not sandboxed, it can do so and write arbitrary files. And then Word uses one more time to talk to launchd to open terminal. Terminal, when it starts, will read the .zshenv file and run arbitrary commands. So that's the exploit from 2020. This, unlike the first exploit that we've seen, this is an Apple issue, right? And what Apple has done basically is to fix the archive utility. The archive utility will extract to the user's downloads folder instead of the home folder if it's coming from a sandboxed app. You can still probably use that for some side loading or something, but it's given how hardened macOS has become, I don't know if it's realistic, but you can still use this functionality. So that's the first thing. The other thing that let's keep in our minds is that dumped files from sandbox apps, from Word specifically, will have the COM Apple Quarantine extended attribute attached for identification purposes. This is not an extended attribute talk, but basically imagine it as if like it's a metadata that is kept on the file system associated with the file that is dropped. And if you are familiar with this extended attribute, so yes, this is the same extended attribute that is used by Apple's Gatekeeper to enforce certain things. It makes a lot of sense because you don't want a sandbox app to drop another app, for instance. The other thing that I will mention is that you can't exploit terminal-based sandbox escapes because terminal now refuses to run anything that has COM Apple Quarantine. So that's just another thing. In 2021, Perception Point found the following idea. Sandbox apps can basically write to their own special container directory. For every sandbox app has a special container directory that they can write arbitrary contents to, right? It's a special directory. You can't write outside of that directory unless it's allowed by the sandboxing rules. But the sandboxing rules do not apply to this container directory. It's completely unrestricted for all means and purposes. So the idea is that you can use the open command, and the open command has specific features. One of them is a --env, and it controls environment variables. You can basically say, tell launchd, hey, start this app, but with this environment variable in mind. You can set arbitrary environment variables, and that gives a lot of power to an attacker. The idea is to basically dump a .zsh_env file, just like before. You dump it in your own container directory, right, which you can write to because it's your own container directory. You can write whatever you want there. And then basically tell launchd, hey, start the terminal app, but the home directory for the terminal app is now my own container directory. Because of that, terminal will start and will look for zsh_env file in the home directory. Because the home directory is spoofed, basically it will run the .zsh_env file, and that's game over. So this is how it looks like. Word dumps the .zsh_env file to the container directory, which it can do. It will use XPC to talk to launchd to start terminal with a spoofed home directory, which is the container directory. Terminal starts, looks for a .zsh_env file in the home directory, which again is spoofed, and will basically run this file. So that was a very cool sandbox escape. Everything is very logical, very reliable. Apple fixed that in the terminal app now. The terminal app locks certain environment variables now. It basically does not allow home to be overridden even by launchd. And there is one more honorable mention from 2022 by Wojciech Regula that abused something very similar, another environment variable called OS install environment to do something very similar. So that's the first thing. The second thing is that terminal now refuses to run quarantine script files as well. So that's the fix. Now, this is my own discovery from 2022. Back in the day, Python came pre-installed as an app, and terminal refuses to run files with com apple quarantine extended attribute. That includes zsh_banv sh, and Python also refuses to run that. So if you had a Python file, you could drop it from Word, but it won't help you that much because you can't have Python run it because of this extended attribute. Also, terminal, if you remember, a part of this fix, they locked the home directory, the OS environment, the home environment variable, the OS install environment variable, and also the Python startup environment variable, which you could have abused perhaps. And then I was looking at at other interesting flags to the open command, and there I found the stdin flag to the open utility. And that what it will do, it will launch the application with the standard input connected to a path. So it's kind of like a neat way to override the standard input. Instead of being your keyboard, you can just say, hey, the standard input is this file. And then the sandbox escape is kind of trivial. You can write a $poc.py, and instead of having Python executed directly, you can supply it as the standard input to Python. It doesn't matter that it has the extended attribute, the quarantine extended attribute, because you can still read the file from Python and treat it as the standard input. So this is how the exploit looks like, very simple. You dump a poc.py, just like that. You use XPC to talk to launchd, which will run Python, which will read the poc.py as the standard input and basically run it. So the most simple exploit ever. And that was like 2 years ago. This was the history lesson that we had. The current state in 2024. The current state is that launch services, everything is super duper hardened now. Launch services checks the XPC client for sandboxing rules. And this means that the entire idea of using open, just like we've done 3 or 4 times already in this talk, all those tricks are essentially dead. You won't be able to use that as far as I've tried, and look, you can't really abuse that anymore. That's issue number one. That's the biggest issue. Other issues are that Python isn't pre-installed anymore, so that kind of sucks for attackers. I like Python. Red teamers can't rely only on Intel architecture. Between 2022 and 2024, ARM is I guess the main focus of Apple, even though they still support Intel quite a lot. So you need to know kind of where you land, but there is a thing called universal binaries if you want to attack a box. And there is another thing called hardened runtime. Hardened runtime, I won't go into lots of details, but it basically means that injections are very, 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 very challenging. Most of the apps that you'll find have hardened runtime and launch constraints and other things that will really not allow you to do a lot as an attacker. So again, there is this question: are VBA macros, are malicious Office documents still a thing in macOS? So I asked around this is February 9th. I asked around February this year, and it seems like not so much. The last thing I've seen was MacStiller abusing my own vulnerability, the one from 2022, which kind of like I guess an honor, but also sucks to realize that you've kind of helped, with a vulnerability disclosure. By the way, every vulnerability that I disclose is a responsible disclosure and never drops 0 days. So what I'm going to talk about today is also disclosed to Apple. So don't run and code your sandbox escapes immediately after this talk. So so that kind of sucked to know that MacStiller stole my my exploit. And then Greg here pointed out to the exploit itself. It's basically the POC that I had from 2022. So they didn't even change the POC. That kind of sucks. Anyway, so when you start something fresh, you're like, okay, let's look at Office, because people still need to run their macros, right? Macros are not created on Office for attackers. They're created for legitimate business purposes. As I know that it's hard to believe, but that's the case. And it does say in the Microsoft website, interestingly, I know that it sounds funny. I am a Microsoft employee, but sometimes it's easier to read the public documents rather than reading the code or scouring for some internal documentation. And it's very, very interesting to see that that the public documentation says that Office 2016 and above for Mac is sandboxed. And it says that unlike, I'll read it here, unlike previous Office apps that support VBA, VBA and the Mac Office Mac app is totally sandboxed. The sandboxing restricts apps from accessing resources outside of the app container. The app container is the fancy directory that I was talking about 3 slides ago. And this affects add-ins as well as the VBA itself. And the idea is that they've added a new VBA command specifically for Mac for Office 2016 and above. And these are the commands. I'll call them 2.5 commands because one of them is basically gives you the Office version. Doesn't do much for attackers. It's helpful for developers, obviously. And those 2 commands are grant access to multiple files, which sounds very interesting, and Apple script task, which sounds even more interesting. So we will assess both of them and try to understand what could be done by attackers. First of all, code execution is what we want, and the most direct approach is usually the right thing. Apple script task basically calls an external Apple script. Now, Apple script is kind of like in my opinion, so don't quote, well, do quote me. It's kind of like an abomination of script languages, in my opinion. It's very annoying. I dislike the syntax, but it is a thing on macOS and iOS. You can use Apple scripts to basically as a scripting language, and it is still there in Mac. It's there by default. Office has allowed to run an arbitrary Apple script from VBA, from VB macros. And the idea is that there is you call this Apple script task command or function, and you give an Apple script file name and the handler and stuff like that. It will basically run it outside the sandbox. And interestingly, that script file must be under the home directory launch application scripts bundle ID. Bundle ID is like com.microsoft.word for Word, for instance. And if you remember from slide number 5 or 6, I don't remember by heart, where I mentioned that when Microsoft fixed the Office sandboxing rules, they didn't just fix the launch agents to be prohibited. They also added this directory right here, and now you can see why. If you have a malicious VBA macro, the obvious thing that the macro could have done is to drop something here and then basically execute it with this feature. And now attackers can't do it. The only thing that I did mention that I did want to look for is directory traversal, like creating symlinks or doing // or something like that in the file name. None of them work, so that's very good. Well, it's bad for attackers, it's good for Microsoft, so yay and nay at the same time. The basic idea is that I did not find a very obvious way to abuse this for a sandbox escape. And as you remember from before, this is the fix that Microsoft have done. And you can see here the application scripts directory. So there you go. Let's move on to grant access to multiple files. You can use grant access to multiple files to write a .zshn file even, right? Because again, this allows you to write arbitrary files, you can call this grant access to multiple files with an array. The array is basically, in this case, it's an array of one element, which is the user's home directory, and then the shn with arbitrary contents. You call grant access to multiple files, and basically it will grant you access there. So this looks pretty promising. You can basically use that to escape the sandbox and have a malicious Office macro. But of course, because this is a secure API, it will pop up this thing. So this is how it looks like the first time that you try. You basically have to click select and then select the directory. You click grant access, and then the file could be written. So that's kind of like a very convoluted way of getting a malicious Office macro to do something malicious, but it could be done for a very unsuspecting user. But it has to be a very unsuspecting user. Interestingly, if you do cancel, and you call this thing one more time, it will just pop up again. So one thing that an attacker could do is basically do it in a loop. Like until it's approved, you can just do it forever until the user says, you know what, fuck it, and then click select and then approves, right? So that's something that an attacker could do even today. But interestingly enough, after you grant access for the first time, second time just works. Even after restarting the app, you can restart the computer. And that tells me a lot. It tells me that there is a persistent user choice. The user choice, the idea that the user granted access is saved persistently. And I was like, okay, where is it saved? And I found where it's saved. And interestingly enough, it's saved under the container directory for Word. If you remember from 10 slides ago, you can write and read arbitrary files there. Like this directory is free for all, even from the Office macro. So it's very interesting that this file, this com Microsoft Word secure bookmarks.plist, actually contains the user choice that says, hey, you know what? You can write arbitrary files to this path right here. plist files are just configuration files for Mac, if you're unfamiliar with them. And you use plutil to print out the data there. So this is very interesting. And there is this question on whether I could actually abuse the fact that I have free access from within the VBA macro to this plist file. This is what we're going to find out in the next 20-something minutes. So the first thing that we can do always is read the file. Because the file is in the container directory, we can arbitrarily read and write to it. It's a binary plist file. Plist files, as I said, are configuration files, but and they come in like 2.5 shapes, I guess, so 3 shapes, and one of them is a binary format. So parsing it kind of sucks, even though you can do it from within VBA. And I didn't go to like a lot of length. I just wanted the POC that allows me to read and understand whether a specific path has been approved or not. So what I've done is to just do some forensics. I understood that strings seem to be ANSI Pascal strings. So first byte is the length, and then there is the string length itself. And VBA script can check the directory if the directory is approved, and by simply reading the file. So if you don't want to spam the user with this kind of like, hey, grant me access right now, and being all suspicious, you can be very stealthy and say something like, okay, can I just create this .zsh end file without popping up this thing, right? So this is how you do it. You basically read the plist file. This is where it is, and you can basically read this plist file in binary format, and then basically look for the right string in it. And this is the implementation. I know that it's ugly. It's not my fault that VBA is not a very friendly language, but this is how it could be done by an attacker. So an attacker could basically, if this is a document that is being opened millions of times or by many people, can basically run the script forever and ever and ever on every machine. And in every opportunity, you can just ask if it just so happens that someone allowed access to this directory. And if so, escape the sandbox. So this is how a script could be stealthy, but you have to wait for someone to do something. So it's not a real vulnerability. It's an abuse of a feature, I would say. The writing to files is the most interesting part. If I could write to this plist file and basically add arbitrary values to it, I win, because that means that I can approve any path that I like without any user interaction, without this interaction right here. So that's kind of where I'm aiming. Interestingly, it looks like it's signed. You see this, the bookmark data key actually contains some signature information in it. There is a date and there is a UUID, like a unique ID there. But I did try, and naively modifying the keys or values there end up being ignored by Office and still creating this thing rather than silently just approving, just like we've done before. So there is the question, how is it signed, and can we calculate the key ourselves? So before we start, we have to talk about how apps work in macOS and how you really select files. If you ever opened Word or anything like that, you can just click File Open, and magically you can just get access to like arbitrary files. But how do you get that access if Word is sandboxed, right? No one. When I first learned about like the macOS sandbox, I had this very same question: how can apps actually get sandboxed apps get access to arbitrary files that normally they do not have access to? And what really happens is that, unlike Windows or Linux, where basically opening in Windows, it's more clear because you have a dialog box. Usually, if you have an app in Windows and you click File Open, the dialog box will run in the same process context. In macOS, it's not like that at all. What happens really is that the sandbox app typically gains access to the specific files if a user selects those files using a different process called macOS Open Dialog. So whenever you want to open a file, it actually does an IPC, an inter-process communication, to another service called the Open and Save Panel service. And this service is unsandboxed, it has full access to the files, and it basically grants the access to the files with IPC. So it's really interesting, the different design between traditional OSs that you guys might be familiar with, Windows and Linux, where basically you open a file because you open a file. But in Mac, it's a bit different. You have to basically pass the ability to open a file to a different app. In Linux, there is something quite similar, in which you can pass file descriptors over Unix domain socket, but this is not a Linux talk. So that's what really happens when you select a file, and there is something that we have to have the right terminology. A sandboxed extension that's the terminology, is a token that is created by the kernel and grants the process possessing it the ability to access certain resources, such as files. So in our case, what happens is that the open dialog, the service, asks the kernel, hey, please create a token for this specific file, and then transfer that token to Office. And then there is this API that is called Sandbox Extension Issue File. You can just call it directly, even though there are high-level APIs to do that kind of functionality. This is how it looks like when you select a file. So you basically say, hey, I want to open the file. This is, by the way, unrelated to what we've seen so far. This is just how you open the file in Word. So when you open a file in Word on Mac, it will create an IPC to the Open Dialog service, which is unsandboxed. This thing will access the file and ask the kernel, hey, please create a read-write token to this file right here, to, let's say, tempquack. Kernel basically creates this token. The token is then transferred to the Open Dialog service and then over IPC to the Word app. And then the Word uses the token to access the file. The token itself is composed of several fields. And most interestingly, it has an HMAC SHA-256 authentication. The key is generated by each boot by sandbox.kxt, which is a kernel extension. So the kernel itself generates a key to sign this token right here. There are other interesting fields there, including volume, inode, and other file system related file information. The file path is obviously there in the token, and the capability. Capability, for instance, is capability to read and write, for instance. This is what we care about. So the conclusions are the following. A process can't fake a token because of the signature, because of the authentication. And the other conclusion is that a token can't persist between reboots because the key is generated in each boot by sandbox.kxt. If you save, let's say, this token for later use, after a reboot, it will be invalidated. The key is no longer the same key. So because of that, what happens, well, before that, there is another thing called security scoped URLs. And this is simply like a token serialization in an NS URL. It's not very interesting. What I'm trying to say here is that there is an upper level API to use this thing, to use the sandbox extension issue file. So you can use the entire next step higher level API. That's the entire thing. The idea is that once you have a token, you can just tell the kernel, hey, you know what, I have a token, please let me pass. That's the entire idea here. And then this is where things get interesting. This is what Word and other apps use. It's called security scope bookmarks. And the idea is that sometimes we want to persistently save the access token, even between reboots. You can't naively use the token as is because the HMAC 256 will be invalidated after the reboot. And what you do is to talk to another service, another unsandbox service called Scope Bookmark Agent. And this guy will create a normal token, but also calculate something called a security cookie. And that cookie is saved with a path persistently. So this is how you basically save the access token. And whenever you want to use the token, what happens when you have a request, you check if in the persistent storage for the security cookie, if the cookie exists and valid, you create a token and provide it to the app. Basically use the API that does not survive reboots. If the cookie doesn't exist, you use the open dialog. Now, I know this sounds very convoluted, so I prepared, again, this graph. What happens is Word says, hey, I want read-write access to tempquack, and talks to the scoped bookmark agent. This agent basically will get the appeal list. It's not done exactly that way. The appeal list is actually maintained by Word, but whatever, and asks, hey, is tempquack approved for read-write with a valid cookie? If the answer is yes, it will basically talk to the kernel. It will get read-write access just the way that we've done before and pass this token to Word. Now, Word has access to tempquack. If we don't have access to the cookie, if we don't have a valid cookie, or if we don't have an entry for temp quack, I mean, what happens is that you have to talk to the Open Dialog service, which will present the the open dialog and asks you to grant access, which is something that the red teamer doesn't want to have. And then the token is passed to Word, and you can also save data later. Scode Bookmark Agent can save the data for later in the pill list file for persistence. So how do you sign a bookmark? How is this bookmark, this thing in the pill list, how is this signed? There are two types of bookmarks actually, but we'll only talk about app scope bookmarks because I didn't find any document scope bookmarks. Perhaps it's a feature that is not used a lot. So app scope bookmarks basically calculate a crypto key. That crypto key is HMAC 256 of a secret key, signing the app bundle. In our case, it's COM Microsoft Word. Now, the crypto key is used later to sign the bookmark data. That's the bookmark cookie. So what do we know from inside the Sandbox app? That's as an attacker, switching hats from an engineer that understands this thing to a hacker or to an attacker. We know the bundle identifier, so we know com.microsoft.word. And all we need is the secret key. If I know the secret key, I can calculate the crypto key. And if I know the crypto key, I can create arbitrary bookmark data and add it to the pill list in order to gain arbitrary access to arbitrary files. That's the idea. The secret key, however, this guy right here, comes from the keychain. Now, if you're unfamiliar with a keychain is basically like a password manager that is there by default on macOS. It's being used for various things to basically store secrets. Now, this is the name of the secret key. The secret key is called com Apple Scode Bookmarks Agent.xbc. And this is not a keychain talk, but basically every entry in the keychain has an ACL, an access control list. And in this case, the access control list for this secret key specifically mentions that the only apps that have this kind of have the access to the key, to the secret key, is the Scode Bookmark Agent, which is not surprising. It means that if I'm an attacker and running inside a Word macro, I don't have access to this item. So it looks like we're kind of lost. This is how things look like. Really, Word. Like the complete thing is that in order to sign this token, like everything is done just like we've done before. But whenever the token is created, the Scode Bookmark Agent reads the secret data from the keychain and then calculates the crypto key, calculates the cookie, and this is what's really being saved inside the pill list file. So just to mention how the signing looks like. And there is this question of what can we do, right? And I thought about it for like a few days, and then I realized that the ACL, the access control list, the thing that we saw here, actually dictates who can read the key. But I don't really need to read the key. I just need to decide on the key. And this is the vulnerability that I disclosed to Apple. The idea is that the ACL dictates you can't read the password, but I can just add one. So you can create from within even a sandboxed, within a sandboxed app, you can basically delete the previous key and decide on a new one. So I delete the previous one, decide on a new one. This is the password. You can see AAA, BC, so on. And more interestingly, I added the big A here, big A. And this flag actually says that the access control list is allowing everyone to access the key. So that's kind of like a win. It basically means that I invalidated all of the previous persistent user choices. So there is some impact on the user experience in the future. But basically, now that I know, I control the secret key, so I know what that is, and I allow everyone to access it, including the Scode Bookmark Agent, it basically means that it could be used. So how does my generic sandbox escape look like? You delete the old key from the keychain. you create a new key from the keychain with a password that we control, right? You can basically do that because it's not enforced by the keychain ACL. Now that you control the password, you calculate the crypto key for an app, let's say com.microsoft.word. Now that you know the crypto key, you artificially sign new items in the security bookmark plist. Now, basically, you call the API before they grant access to multiple files, which will use the Scode bookmark agent, which will read the same thing that we added before, the same plist. We'll use the same key that we controlled to validate that the entry is correct and get us access to write to .zshn. And then I dump .zshn file, and now I wait for terminal or something to trigger. Or I can do whatever I want. I can even create a launch agent that way, same idea. So that's the generic sandbox escape that I had. Interestingly, exploitation, by the way, took me a long time. There are some very fine details that you have to come up with when you artificially sign new items. But interestingly, I got stuck here. I still got the Scode bookmark agent to not respect my new password. And the thing that I discovered is that it doesn't ask for the secret key every time from the keychain. It actually just asks one time and then keeps it in memory with the understanding that it won't change. It's a long-term key. So what I ended up doing is that I have to either kill it or wait for a reboot. I did not find an easy way to kill it from within the Sandbox app. So the exploit becomes even much harder. You have to maintain state between reboots. This is the actual Sandbox escape that does work. You basically check for a state file. Oops, sorry. If the state file doesn't exist, or the process ID of this Scode bookmark agent is the same thing, it basically means that we didn't have a reboot. So what you do in the macro is to delete the old key from the keychain, create a new key with a password that we control, just like we've done before. We calculate the crypto key and create a new state file and wait for a reboot. If this thing does not apply, it basically means that we experienced a reboot, right? And what we can do is artificially sign new items. We know that the Scode bookmark agent fetched the correct key. And what we do now is to do what we've done before, right? So this is the generic sandbox escape that I have, which is very convoluted, but does work. One thing to keep in mind is that the issue with the ACL that I mentioned, the fact that the ACL does not prevent you from deleting and creating a new password, opens up other techniques that are not vulnerabilities per se. For example, if you're using any Chromium-based browser, let's say Chrome for fun, the cookies and everything that you use are basically encrypted. And they're encrypted with a key that is saved in the keychain. And only Chrome, in my example, can open them. So one of the things that you can do as an attacker is delete that key from the keychain, define your own key. It will invalidate all of the cookies from Chrome, so there is a user experience. But from that point on, as an attacker, you can just wait for cookies to be written to disk, and you can decrypt them because you control the password. So that's like a bigger issue, and red teamers can use that ability to wreak havoc or gain any secret information that normally you could not get. Some conclusions. I don't know if we have time for questions, but some conclusions. The attacker strategies that I found for malicious Office macros are the following. You can either nag the user until the permissions are approved. My favorite, I guess. You can be stealthy and check for permissions and then drop the .zshn file. Or you can rely on a very complex exploit that relies on a reboot, which is what I described in the previous 10 slides or so. Apple makes sandbox escapes really challenging, even though I know that there has been a Black Hat talk just a few days ago about some newfound sandbox escapes, so you should check it out. I did not follow up completely on that. But it is getting harder and harder to escape the sandbox. And Office VBA macros are kind of safe if you think about it, because these are very convoluted things. So they're kind of safe, but kind of not, but kind of are. And you get to choose like whether you feel safe or not. With that, thank you so much for listening and for tuning in. Thank you. And I don't know if we have time for questions. If there are, I'll try to answer them. I guess
Yes, we do have time for questions.
Yeah. If there are any questions, you can write them in the chat, or I see that there are some. I don't see anything that's written in the chat that looks like a question, so hooray. Okay, you can feel free to reach out after. I will be answering questions. I will not be giving exploitation code, but besides that, you're free to ask me whatever you want. Thank you so much.